Okay, this one here. Ted drove 10 blocks looking for an address. He then had to drive a half a block in reverse to reach it. What expression gives the distance driven? It's kind of a weird thing, actually. 10 blocks plus negative 1/2 equals 10.5 blocks. You could. Just using absolute value. Okay, let's take a look at this real quick. Absolute value is a function that contains an absolute value expression. So let's talk about this right here. Anybody have any idea what the graph of that might look like? Why, Dom? Why is it a V? Yeah, let's think about this. Isn't the absolute value, all the y values are going to be positive, aren't they? Yes? No? Maybe?
Yeah. No.
If I stick in a -1 here, what's the absolute value of -1? 1. If I stick in a +1, what's the absolute value of +1? 1. If I stick in -10, what's the output going to be? 10. Y values will be positive. This is the parent function. Let's graph it. Get your calculator out. Shh. You guys really have to stay with me here. Arrow up, turn your plot off. You don't want any plot on, and you want to clear all your equations. Nothing, okay? Nothing. Are you there? Delaney and Catherine, I worry that you're talking too much, okay? All right, now, absolute value. Yours might look a little different than mine, okay, but it's in the same spot. So push math, the math button here on the left side. Go over to number. And there's ABS right there. So you push enter. You push enter. Now here's where yours might look different, but it means the same thing. You might have ABS and a parenthesis. It's fine. You still put X in, and then I arrow out of it. You have to close your parentheses. Okay? Are you good with that? Don't push graph yet. We want to all have the same graph. So push zoom 6. Oh, I didn't. There you go. Standard graph. Absolute value. Now let's think about what this is graphing. All right. Look. If x is 3, what's y? 3. If x is 4, what's y? 4. If x is -3, what's y? +3. If x is -5, what's y? +5. Okay? So that's why it's a V graph, like this. The y's will always be positive. Do your arms like this. We're going to be moving a little bit. Okay. Now let's have some fun. Stay. You can put your arms down. Let's go to the table. You ready? Shh. Second table. Look at this is just what we were talking about. I'm going to arrow down a little bit to the ones and the -1s. Okay? We can see here when x is -1, y is +1. When x is 1, y is +1. These are inputs and outputs. Now, let's go back to y equals and arrow down to y2. Now what I want to do is I want to do 2 times this function. Don't do anything. Don't get all excited. Let's just think about this. 2 absolute value x. Again, you might have ABS. X parentheses is fine. Don't push graph. Let's think about, if I'm multiplying all of my input by 2, what's going to happen to all my output? It gets steeper, doesn't it? It grows faster. It's doubling. So I had this. Everybody do your arms. If I multiply it by 2, what's going to happen to it? It's going to climb faster, right? The y values are going to be bigger. Let's see if that's true. Let's graph it and see. Oh, there it is. It's steeper because the y values are being doubled compared to this one. Yes? Okay, go back to y equals. Arrow down. Do 0.5. Shh. don't 0.5 absolute value of x. Okay, you all probably know what's going to happen.
The sun's up.
We're taking the y values from the parent function and we're cutting them in half. Now they're half as big. So here's my original parent graph. What's going to happen to my y values? They're shrinking. They're getting squatty. Squattier. Squattier. Funnier and squattier. How's that for good grammar today? Okay? So this graph looks like this. Shh. There we go. Kind of cool, huh? If you don't believe me, let's look at the table. Look at the difference in the tables. This is the parent function. This is the times 2. The y values are doubling, aren't they? Yes, yes? Okay, would you look at that? Here's times 1/2. They're half. Okay. All right, we looked at the calculator. We're going to talk about this, break it down a little more. So let's write this here. Y equals ax minus h plus k. I actually want to go back up here and write up here. Did you write this up in the corner? Obviously, you're going to be using this a lot. This is a stretch or a shrink. The A affects the stretching or the shrinking because you're multiplying by a number. It could also make it flip. The H affects the horizontal movement.
Wait, what is it?
Stretch or shrink. Oh, sorry. Left or right? H affects horizontal movement. Why is that so funny? The K affects,
Up and down.
yeah, up or down. Every time I write, it gets funny, doesn't it?
Yeah.
Just don't write. Okay. So let's go back down here. So you always want to compare it to the parent function. So we're going to do some dashes. Or just some little dashes here. 1, 1, 2, 2, 3, 3, 1 negative 1, 1, 2, 2, 3, 3. This is my parent function. Y equals the absolute value of x. This says to add 3 to it. So this affects the up and down movement. So which way is my graph going to go? It's going to stay exactly the same, but it's going to move up 3. Okay? Stays exactly the same, but it shifts up 3. Now let me ask you, what's the vertex of this new graph? Where do you think the vertex is? Right here, and the coordinates are 0, 3. Okay, write that down. All right. Look at the difference here. This plus 3 is where? It's inside, so it shifts which way? But look, we started with a minus h. So in order to get it to be a plus 3, we had to stick in a negative 3, didn't we? We had to stick in a negative 3, which means it goes to the left. Y equals the absolute value of x minus h. We plugged in negative 3 to get x plus 3. So shifts left. Shifts left. So I'm going to draw my parent function. And then I'm going to shift it left 3. What was that?
She dies. Not sure who, but she dies.
Okay, don't turn it over yet because we have to observe something. What's the vertex here?
Negative 0.
Okay, let's stop and say, If I was just given the equation, do you think you could come up with h and k? Where do you think the 0 came from? Excuse me, where do you think the 0 came from? Where do you think the 3 came from? Look, we added 3 outside, which is what letter? We added 3 outside, which is what letter? We added a negative 3 inside, which is what letter?
H.
Did we add anything inside here? No. What did we add inside here? A negative 3. Did we add anything outside here? No. So where do you think the vertex came from, this equation here? What letters? H and K. The vertex is always going to be H and K. Always. Always, always. Okay, let's do this last problem. We're not going to do this on the bottom. We're just going to do this one right here. So, a landscaper sketches a design for a triangular shrub protector on graph paper with the points 0, 0, 10, 0, which I'm just going to say is right here. It's kind of hard to see. And 5, 6. 1, 2, 3, 4, 5, and up 6. It's kind of hard to see. I'm just going to say it's here. There's my graph, okay? Write an equation for the shrub protector. So, 0, 0. I just got him from here.
Oh, it's just the time was there.
Yeah. So I need to write an equation that looks like this. What I need to write the equation is H, K, and A.
Oh, I know it.
Those are the 3 things I need. Now, we already know how to get HK. Where is HK on this graph?
The vertex.
It's the vertex, which is right here. So H is 5 and K is 6. So I can plug that in right now.
Can you plug in X and Y?
We don't need to. It's an easier way. You could. A is actually just the slope. It's the slope. It's the slope. Okay? There's just one trick you got to think of. Okay, so the slope here, if I do 6 minus 0 divided by 5 minus 0, I get 6/5 for the slope, right? The only problem is you have to think about, if this graph is opening up, it means it's a positive, right? If it's opening down, that means it's a negative. So you'd have to still get the slope, but you have to write it as a negative 6/5. And you're done.
Oh my gosh. Good job, Ben. Wait, how did you get the slope?
Just the difference between these 2 points.
Oh, yeah, like the.
Or rise over run, up 6 over 5, however you want to look at it. You need graph paper, page 127, 3 through 25 odd, and 39. But 21, 23, and 25, you don't have to graph, just explain with words what's happening to the graph. Like shift up 3, stretch of 2, kind of, all right? Explain with words, no graph.